Hi guys, welcome to Algorithms Made Easy. Today we will go through the day 25 problem from August Leetcoding Challenge, wherein we will find the solution to problem minimum cost for tickets. Please like the video, and if you are new, don't forget to subscribe to our channel so that you never miss any update. In a country popular for train travel, assume that you have planned some train traveling 1 year in advance. The days of year that you will travel is given as an array day. Each day is an integer from 1 to 365. Train tickets are sold in 3 ways: a 1-day pass, a 7-day pass, and a 30-day pass. The passes allow that many days of consecutive travels. For example, if we get a 7-day pass on day 2, then we can travel for 7 days. Return the minimum number of dollars you need to travel every day in the given list of days. For example 1, we are given days array and cost array. Given this plan, the minimum price can be observed if we take a 1-day pass on day 2, a 7-day pass on day 3, and a 1-day pass on day 20. This will cover all the days and give a minimum price of 11. Similarly, for the second example, the note attached with the question says that we can have days array of maximum 365 with values ranging from 1 to 365. The days will be sorted in increasing order. The length of cost will be 3. And the prices will be between 1 to 1000. Taking this example, the days array represent the day of travel. The cost array represent the cost of 1 day, 7-day, and 30-day pass for travel at position 0, 1, and 2 respectively. Our goal is to minimize the cost. The question can be solved using dynamic programming. We will take a DP array of length equal to the last day of travel plus 1. Wherein we just need to focus on the highlighted days as these are the days of travel. To minimize the cost, we will compare the 3 costs: cost to buy a 1-day ticket, cost of buying a 7-day pass, and the cost of buying a 30-day pass, which can be expressed as follows. Since day 1 is present in the input days array, it means we would be traveling on this day, and so we would need a ticket. Thus, we need to find out the cost. Minimum money spent till the current day can be found by calculating the minimum between all 3 costs. That is, if I bought a 1-day ticket or a 7-day pass or a 30-day pass. We will try reducing the cost spent till current date. So, we will be calculating the cost ending on the current day. These costs can be given as shown on the screen. The minimum cost till date after buying a 1-day ticket for day 1's travel will be the cost incurred till day of I-1 plus the cost of 1-day ticket for the current day. This becomes DP of 0 plus costs of 0. Similarly, if I buy a 7-day pass for travel till current day, it will be given by the cost of travel incurred till 7 days before the current day plus the cost of 7-day pass that will cover the current day's travel. This can be given by equation dp of I-7 plus costs of 1. And on the similar note, the cost of buying a 30-day pass can be expressed as dp of I-30 plus costs of 2. Substituting the valid values gives the first amount as 2. But as I-7 and I-30 becomes negative index, we will substitute 0 for it, because these are not the valid days and so the cost for it would be 0. So, the price for 7 days and 30-day pass till day 1 becomes the cost of the pass itself. The minimum of all would be 2 in this scenario. So we update DP of 1 to 2 and move to the next day. Since day 2 is not present in days array, we just copy the value of previous day in day 2. This gives us the cost incurred till day 2 to be $2. Moving to day 3, as this is also not in the travel plan, there would be no new cost incurred, so we copy the previous value. Coming to day 4. As we are going to travel, we need a ticket and thus we need to update the cost. So we again find all the 3 costs. The cost to buy a 1-day pass will be dp of 3 plus costs of 0. The cost to buy a 7-day pass will be dp of 4 minus 7 plus costs of 1. And the cost to buy a 30-day pass will be dp of 4 minus 30 plus costs of 2. For days 7 and 30, the backdated DP values still do not exist. So they become 0 and the minimum of 4, 7 and 15 is 4. So we update it in the DP array and move ahead. Since day 5 is not present in the days array, we just copy the value of previous day in day 5 and move forward. As day 6 is in the travel plan, we calculate the cost again. This time the value gets updated to 6. For day 7, we can see that we could either buy a 7-day pass that would have covered the days 1, 4, 6 and 7's travel. This would also minimize our cost. So we update 7 in DPRA for day 7. For day 8, we see that the cost of buying 1-day pass gives us 9, and also if we buy a 7-day pass on day 2, gives us 9. Both are equal and minimum, so we update the DPRA with 9 for day 8. Since we have no travel plans from day 9 to day 19th, we populate these with the value from the previous day. Lastly, we calculate for day 20 in a similar fashion we did for the rest of the days and get 11 as minimum cost till date. So, we return the cost at DP of 20, which is 11. Here's the algorithm. We initialize a DPRA of length last day of travel plus 1. We also initialize a set and add all the travel days in it. We then loop from I equal to 1 to dp.length minus 1 and fill it. We find the three costs C1, C7 and C30 as given. Now we check if the current day is a travel day by checking if set contains I. If yes, we update dp of I with minimum of C1 plus costs of 0 and C7 plus costs of 1 and C30 plus costs of 2. Otherwise, we just update it with the previous value from DPRA. At the end, we return the last element from DP. The time and space complexity for this approach is O of W, where W is the last day of travel. Here's the actual code snippet from the method. You can also find a link to this code in the description below. If we closely see, the highlighted blocks are redundant and not really needed. So here's a homework for you. Can you try to eliminate the space and time used to process these elements? Here's a list of a few more DP problems that we have covered in past and could help you in understanding different flavors of dynamic programming questions. So do try this. The link to all the questions is in the description below. Thanks for watching the video. Please like, share and subscribe to our channel. Also, let us know your suggestions and thoughts in the comment. See you in the next one.